All right, welcome back, everyone. In this video, I want to define what a matrix is and talk about some notation and some terminology that we often come across when working with matrices and vectors. So a matrix, first of all, is a two-dimensional object. So we have a row and we have columns. And all of the values in a matrix, all of the elements in a matrix need to be of the same data type. So a matrix is what we would call a homogeneous data structure. So it's possible that we have a matrix of logicals. We could have trues and falses for all of the entries. We can have a matrix of character strings where each element in the matrix is a string of characters. More likely than not, when we're working with matrices, we're working with numeric data. So most of the time, our matrix is going to consist of entries that are all numbers, all numerics. But you can't have a matrix that has some elements that are numeric and some that are logical and some that are character strings. So like vectors, matrices can only contain a single data type. And for the purpose of our videos, we're going to be working with numeric matrices. So our elements are going to be numbers that we store in a matrix. And we can describe the size of a matrix by indicating how many rows and how many columns are in the matrix. And we describe the size by first indicating how many rows the matrix has, and then we indicate how many columns the matrix has. So this matrix A that we're looking at on this screen, you can see that we've got 1, 2, m different rows of data. So we start with the first row, the second row, and down here, the very last row is row m. And then I've got the first column, the second column, all the way out to the very last column, which we're calling n. So this matrix, this kind of generic looking matrix, we would say has m rows and it has n columns. So this is an example of an m by n matrix. So the notation that we use is like this cross or this times notation. But when we read this, we would say this is an m by n matrix or an m times n matrix. But what's important is first comes the number of rows, then the number of columns. And we indicate the kind of which particular element in the matrix, if we want to refer to an individual element in the matrix, then we use some subscripts where we indicate the row that the element sits in, followed by the column that the element sits in. So this element over here, A12, means this element is sitting in row 1 and column 2. So that's what A12 means. A21 means this is an element that is in row 2 but column 1. So that's the 2 is row, the 1 tells us the column, and so on. And so this last element over here, AMN, is just the element of matrix A that is in row M and column N. So just know that whenever we describe the size of a matrix or we're indexing a matrix to refer to a specific element of the matrix, it's always first the row index, then the column index. And that's exactly how we index in R, right? The first index is the row index and the second index is for the column. So that is nice that we have this consistency. So matrices are these two-dimensional objects where we can store, say, numbers, arrange them in rows and columns. If we have a matrix that has just one column, we call that a column vector. And when we have a matrix that is just a single row, we call that a row vector. And since we want to denote kind of vectors differently than we might want to denote a number, we use different notation for vectors. So we typically write vectors in bold. So we'd use a bold A, a bold lowercase b. So first of all, vectors we typically denote with lowercase letters. Matrices we tend to denote with capital letters. So a capital A is for a matrix, a lowercase a is indicating a vector. And to differentiate vectors from, say, variables that are just like one single number, we usually denote vectors in bold. If you're writing by hand, it's not always easy to write something in bold. So sometimes you might also see the notation with the arrows above the letter. So A with an arrow over it might indicate a vector, B with an arrow over it might indicate a vector. This is common notation that you often see like in engineering, in physics, or even in some math classes, they'll use this arrow notation. But for our purposes, since we're typing things, it is easier to show typed stuff in bold. I'm going to be using bold to indicate vectors and matrices. So we would say a column vector A is P by 1. So the P would indicate how many rows the matrix has, and this 1 indicates that it has one column. So A that we're looking at over here, this is a column vector, and it has P entries. So all of these P entries are lined up in one column, and we can consider this a matrix that has P rows and one column. Row vector B that I'm looking at over here, this is also a matrix. We can think about this as a matrix, which is a 1 by P matrix. It has one row and P columns. So that's what a row vector might look like. And so for our purposes in this module, we're mostly going to be working with column vectors. So if I say the word vector in this context, that means I'm referring to a column vector unless I specifically say row vector. So I will probably say column vector, but if I forget the column qualifier and I just use the word vector, that should be a column vector to you. And I also just want to mention that just for like spacing on pages, when we're typing out vectors, sometimes you might see a column vector written out as a row with commas like this, just because it takes up less space on a page, less vertical space on a page than if you were to write it as a column. But I will try and denote column vectors in columns properly here because I'm not printing this on paper. We're showing this on the screen, so I don't need to worry about my vertical space. But when you're seeing things printed, sometimes they might try and condense the vertical space and display a column vector as a row, which might be a little confusing. So I just want to make you aware of that. But for us, we're going to be working with column vectors, and we'll represent them as columns for the most part. Okay, so that's some of the notation about matrices and vectors. It is very important that you describe the size correctly. It's a pair of numbers, and the first number indicates the number of rows, and the second number indicates the number of columns. And that's also how we index and refer to individual entries inside of a matrix. In the next video, we'll pick up and talk about how we can create matrices in R.